So friends, you know about the order of reaction, molecularity, rate constant and rate law. And you know that there are different types of order of reactions. It may be zero order of reactions, it may be first order of reaction, second order reaction, fractional order of reactions, even negative order of reactions. And the present definition of this order of reaction is the sum of the powers of the exponential terms of the reactants, which must be specified so that the system can be explained. So today I will discuss a general order of reactions, that is called the nth order of the reactions. And if you understand this nth order of reactions, you are able to write the unit of that order of reaction, the integrated equation of that order of reaction, as well as the half-life of that reaction. So listen carefully, what is the nth order of reaction? N may be 2, N may be 3, N may be 3 by 2, like that. So that is called the nth order of reactions. Now for this, I am again using a very simple system. As A is converted into B. And order is rate constant of the N. Kn means rate constant for nth order. So I can write like that. Of A is equal to K N A sum of the powers of the concentration term, sum, add. Suppose there are two reactants A plus B, and order with respect to A is N1, order with respect to B is N2. So the total order will be N1 plus N2. So sum of the powers of the concentration terms, which must be raised in order to explain the complete reaction. That is the order of reaction. So nth is the order. So let me solve. So again rearranging the variables, concentration and time. So I can write like that. An is equal to K dt. Same thing you have already solved now. Reversible first order reaction, you have already solved first order reaction, second order reaction. So our first part is that always we have to integrate it to know the system. System is same. So A minus N d A 1 to 2 minus, I said just slightly change this, K N dt We have already studied in, I think, school level or college level. And very first xn, you all know all these things. Integration. So nothing new. Very elementary thing. And you have already now experienced that whether it is a reversible first order or third order or second order or nth order, the system is same. First we will write a differential form because the change in concentration with respect to time. Now we have to know the very small, infinite small change. So that is summation, one type of integration is there. So I can write like here. So 1 to 2, you know, final minus initial. So if it is 2, so A2 minus n plus 1, because this is x plus n plus 1, n value is minus A1 plus 1 minus n plus 1, same thing, or is equal to minus kn T2 minus T1. That's all. That is your, of course, n is not equal to 1. So you can, by that formula, you can easily solve any system. That is a normal system. But again, what we do, we assume that at the initial point, same system. But I am not specific about the first, second or third. But system is exactly same. Just few minutes ago you have seen the second order, where we also assume same thing, that t is equal to 0. That is very difficult to differentiate between a and a0 or whatever it is. So same thing we use. So in place of a2, I can write a, the final state, minus n plus 1, and this is the initial condition. So a0 minus n plus 1, 1 minus n is equal to minus kt. This is our equation. And we can use the kn, nth order of reaction. T is the time, A is the initial concentration, and A0 is the concentration after the time t. So you can write like that. But we have to determine a concrete equation for half-life as well as for the rate constant. So that is called, sometimes there is no argument, but again that is called the mathematical simplicity. Just we have to, so both the equation, both the side is to be multiplied by a magic factors, that is 1 minus n a0 n minus 1. I will tell you why we are doing all these things. You can understand all these things. Up to this, I think there is no problem. Simply we integrate these things. Then what I do, I will multiply both the sides with this 1 minus n a0 power n minus 1. The whole thing. What I will get? What I will get? That means this part is first multiplied with this part is multiplied by this part is multiplied by this. So this 1 by n cancel out. So it will A0 minus n plus 1 multiplied by A0 n minus 1. This denominator part is cancel out. Minus, now this A0 is multiplied by this, again this cancel out, so it will get A0. Same thing, you know, power to power, so minus n plus 1 plus n, you know, ax2, then a 2 plus 3 like that is equal to, now minus kt multiplied by this. I want to remove this minus to avoid all these things. So it will be n minus 1 kn t a0 n minus 1. Do you agree with me or not? And you all know that mathematics students can solve it, this n, this n, this n, and power 0 is equal to 1. Very good. So, and then I am not happy with these things. We can write 1 by a, like we can write like that, 1 minus n, 1 by a0, like that. But it is better to write simply. I can write like that. You can understand these things. One is 1 minus n, is n minus 1, then I have to compile it. So what I do, a divided by a0, divide, why? Because I have changed these things. 1 minus n, isn't it? Because just you minus it. So minus 1 is equal to n minus 1 kn t a0 minus 1. So this is the simplest. Of course n is not equal to 1. You know that whenever we solve any type of integrated rate law, it is very essential for chemical kinetics that you must know the unit of that rate constant. You must know the half-life period formula, because that is the characteristic of a chemical reaction. So it is very important to know the half-life period. Half-life is that actual concentration when that the concentration of the reactant is 50%. So I have to determine the half-life period or half-life of that equation. So this is actually important. So it is a common for, now again this is a homework question that I am giving you the general equation. Then you have to write the rate constant for second order or third order, and how do you graphically as well as the, because there are two methods. Either you have to apply some graph, and as well as by the integration method you can also calculate the rate constant. So let me write the half-life formula. Right. Now you know that half-life can be explained many, in some books it is written like that T half, or even some books it is written like T 0.5, whatever it is. Sometimes it is T half, or T you should not write, but better is write the T half. T half is half-life. And when the initial concentration. Suppose you are using 5 milligram of or 10 milligram of ethyl acetate. So after 10 minutes, that 5 gram become 2.5, just half. That is called the half life. So A0, in order to determine the T half, generally what we do, we will change this equation. How do we change this equation? Now half life means when the initial concentration become 50%. So what we do, that A means half life means A0 initial concentration divided by 2. So if I substitute the value of A here, that is A0 divided by 2. So this A0 cancels, so half 1 minus n. If I want to convert it, so it will be automatically 2n minus 1 like that. I change to minus 1. Minus 1. Just I change. Is equal to n minus 1 T half Kn A0 n minus 1. Last step, that T half is equal to n minus 1 this part divided by n minus 1 Kn A0 n minus 1. So I have written two equations. One is for rate constant of nth order of reaction, and second is the half life for nth order of reaction. Now the last part is that how do you graphically calculate the rate constant of the nth order of the reactions. So for that you have to plot a graph, and suppose you are performing one experiment. Say for example, decomposition of hydrogen peroxide you are also doing in your practical classes. In order to determine the half-life, you have to change the initial concentration of hydrogen peroxide. Suppose we need the 3 half-life or the 4 half-life like that. Because if you want to plot a graph between the half-life and A0 and whatever it is, so we need the different at least 5 or 4 concentration of the A0. So what you do? We will do, suppose I take log or natural log, whatever it is. T half in terms of minute, in terms of second is equal to natural log of 2 n minus 1 divided by n minus 1 Kn और kn को हम यहाँ भी लिख सकते हैं। Write minus n minus 1 like that. Natural log of kn and a0. Yeah, kn a0. You can write like that. So if you plot a graph, yeah, kn you can write in here is also you can write kn, natural log of a kn. You just slightly modify it. Okay, suppose kn you can keep it here. kn को हम यहीं रहने देते हैं. So if you plot a graph between t half, natural log t half, and natural log of initial concentration, so you can create a straight line. So from intercept you can determine the kn, but I am talking about the order of reactions. Right? n minus 1 can be determined. But the problem is that how do you calculate the half-life? Because for any type of plot at least 1, 2, 3, 4 or 5 values will be required. At least 5 values are required. It may not be passed through the origin. So at least 5 half-life values are required. At least 5. So what you will do? Normal process. Take different concentration or initial concentration you have taken and you time t, suppose like that. So you first, second, third, fourth, 50% you have to calculate. So t half 1, t2, t3, t4 like that. Different. Change the concentration of A0 or suppose 5 milligram, 2.5 milligram, 1.25 milligram, 0.72 milligram. Then corresponding time. 5 is converted into 2.5, 2.5 is converted into 1.25, 1.25 converted into 0.75, and that particular time is the half-life. And initial concentration is in your hand because you initiated that experiment. So this is the beauty of the nth order of the reactions. So if you understand the nth order of the reaction, so in your homework, that with the help of this half-life period formula, that means suppose I am giving you that calculate the half-life of a second order reaction. Tell me, calculate the half-life of a second order reaction. Half-life of a second order reaction where n is equal to 2. Suppose n is equal to 2. I just want to know the half-life formula, half-life period formula for the second order reaction. So what I will do, this 2 minus 1, so 2 minus 1, 1, n minus 2 minus 1, so it will only take rate is equal to inversely proportional to kn and a0, again 2 minus 1, 1. So you will get simple thing that you see, you check from your book, 1 rate constant and a, whatever it is, a0 or a whatever it is. This is the for the if it is for first order, because it is not suitable for n not is equal to 1. because it is 0.693 divided by k in first order. For second or third order, you'll get third means you write like 3 minus 1 2, 2 minus 1 1. Then you can calculate the third order reaction. Okay, thank you.